Hi guys, good evening. Can you hear me? Hello. Can you hear me?
Yes, sir, we can hear you.
Yeah.
Yeah, we can hear you.
Yes, yeah.
Let us start session. If anyone unable to hear me, just rejoin into session. Rejoin into session. Rejoin into session. Yes, let us start. Day 3. So day 1, all the introductions completed. Yes, so day 1 topic. So day 1, all the introductions. Yes, your batch. Yes, day 1. Nothing, all the introductions about me, about course. Next, what is prerequisite, course contents, what next after this course, all that introductions completed. Just only introductions discussed on day 1. Yes, day 2, yesterday topic, day 2. So day 2 just Java. Yes, about Java, Java past, present and future. These things were discussed. So what is Java? Yes, let us review yesterday's class. So what is Java? Java is an object-oriented programming language. Okay. So Java, JDK software. JDK stands for Java Development Kit. JDK from Sun Software. Now it is with Oracle Corporation. Okay, these things we have discussed yesterday. That history, all that history. JDK 1.0, first version of Java released in the year 1995. Yes. So first version 1.0 released with below features. Yes, today topic is this. Yes, about these features. Today we'll discuss about this feature. Today about this topic. Independent platform, portability, hoop language, scalability and security. These features. 1.0 with these features. Next 1.1 in the year 1996. See in 1.1 Java divided into the JDK divided into 3 editions like Java Standard Edition, Java Enterprise Edition, Java Mobile Edition, 3 editions. Okay. Yes, our course is Java Standard Edition. So later next different versions. Yes, out of these versions here, main version is JDK 1.5 called as Tiger version. Yes, released in the year 2004. Yes, many features were added. So you can Java got the success with JDK 1.5. Yes, almost it was taken for 10 years to become success. 10 years to become success. Okay, right? So finally JDK, totally 4 editions. JDK totally 4 editions. Okay. Yes. Java Standard Edition is Java technology, means our course. Enterprise Edition is a application development here, application development part. Yes, all frameworks comes on this area. All frameworks. In frameworks using core Java concepts means yes, our syllabus. Okay. Yes, it's a application development. See these kind of applications like WhatsApp, Facebook, Twitter. These are the applications. These applications were developed in Java. Like there are different kind of applications. Okay, right? Yes, Java frameworks. Here different frameworks. What's the purpose of different frameworks discussed yesterday? Okay, so what is framework? Framework is ready-made one, ready to use. Okay, so different frameworks like Struts framework, simple web applications, Spring and Hibernate framework is for enterprise applications, large scale transactions, very big applications. Okay, next ERP applications also we can develop. Next, Hadoop and Spark frameworks for big data. Yes, to handle big data challenges like storage and processing. Okay, right? Yeah, these all the topics yesterday discussed. So what's a framework? Yes, about framework discussed. Ready-made one, ready to use. Okay, yes, advantage of frameworks here. Advantages. Yes, we can reduce the codes, time of development reducing here, cost of project reduced here, quality product also can be developed here. So generally client expectations, these things like quality products, less cost, less time, okay, less maintenance. So these expectations we can achieve using frameworks. With frameworks, we can achieve these things here. Okay. Yes, even some general example like ready-made houses. Framework is something like a ready-made houses. Okay. Yes, see this. By the year 2010, 90% of existing applications were migrated to Java. Reasons explained. Okay. So main reason, yes, Java is independent platform. Because of independent platform, most of the clients were migrated to Java. Okay, Java independent platform working on Linux based or Windows, Linux, anyways. Suppose if applications are Windows based, there is no security. Windows is not secure. For this purpose, Linux. You have to work on Linux compulsory Java. That's it here. Okay, that history, all that discussed. So why Java got this much of popular reasons also discussed. So lakhs of applications were developed in Java to support lakhs of applications. How many Java resources? Millions of resources. Millions of resources. Millions of resources. Yes, these concepts we discussed yesterday. Okay. Yes, today topic. Today. Yes, features. Java features. Java features. 1 second. Yes, let us start this topic here. Yes. Now these are the features here. Independent platform, portability, object-oriented programming language, scalability, and security. Okay. Yes. See this here. See here. Yes. Here directly explain these features may not be understanding. To understand these features here, some software basics required. Some basics knowledge here. To understand directly, I can explain but may not be understanding, but this is not right way to explain directly here. Okay, so before going to all these features, let us see some basics. Okay, basics like operating system, what is OS? Yes, you must have OS knowledge, how OS is working, about OS behavior. See, when Java program running, yes, what's a OS behavior? Suppose C program running, that behavior, yes, you must have that knowledge, OS knowledge. Okay, next, yes, here about interpreter. What is interpreter and a compiler? Interpreter and compiler. Interpreter and compiler. Yes, apart from this, about exe file and the dot class files. Okay. Yes, apart from this, yes, low level languages and high level languages. Low level and high level languages. Okay. Yes, if you have this idea, then easy to understand all these features. So before going to these features, let us start with basics here. Like what is OS, what is interpreter and compiler, what is exe file, what is dot class file. Yes, what are the low level language, high level language. Let us see about all of these things. Okay, so here I'm starting with basics. Yes, starting with basics. Okay, basics from the scratch. Let us start from the scratch. Yes, even non-IT background guys also can understand it. Just I'm starting from the basics here, starting from the very scratch. Okay, there are some software fundamentals. Okay, here the software fundamentals is somewhat interesting here. Interesting. Here these are some unknown facts. Even guys are having 10 years of experience. Yes, even they also they don't know about these software basics. Here my intention is you must have every knowledge, including basics, including fundamentals. So when you facing interview, yes, you have to answer every question, including basics. That's the reason I'm starting basics. Directly understanding Java a little bit difficult. So before going to Java, there are some prerequisites, software basics. Okay, after finishing that software basics, I will enter into Java. Software basics matter of two classes, today and tomorrow. Tomorrow I'll be entering Java only. Okay. Yes, just a matter of one class. Matter of one class is not an issue. Okay, yes. Yes, let us start. Starting with basics here. See, I'm starting from very scratch. See, computer ware basically two categories. First one, yes, hardware. Second one, software. Hardware and software. So hardware and software. Okay, hardware. These are physical components of a computer. Hardware, physical components of a computer. Physical components like a keyboard, monitor, hard disk, motherboard, like different kind of things. Hardware components. Yes, we can touch all that parts here. Okay. Next is software. See, hardware. This is not our part. Yes, ours is software part. We are the software engineers. We are the software. So let us start with software. Software. So what is software? See, software. Yes, in software. Yes, everything is a program. Everything is a program. Everything is a program. Yes, software basically two categories. Software basically two categories. Software basically two categories. Okay, first one, yes, system. Yes, first one, yes, system software. Second one, application software. System software and application software. Software basically two categories: system software and application software. So first about system software. What is system software? Yes, system software. 1 second. Let me have some water. Yes, system software. So what is system software? System software. Yes, it interacts with the hardware components. System software, it interacts with the hardware components. Okay, it interacts with the hardware components. Okay, the system, what is system software? Yes, it interacts with hardware components. Okay. Yes. System software, it interacts with hardware components. Example OS. OS is a system software. OS can interact with hardware components, operating systems, and even device drivers also. Operating systems and device drivers. Operating systems and device drivers. Okay, operating system and device drivers. Okay. 1 second, some office message, just a minute. My colleague message. Yes. System software, it interacts with the hardware components. Yes, example operating systems and device drivers. Okay, next What is application software? Next, about application software. What is application software? Yes, application software. Yeah, this is for the purpose of application development. Application software. Yes, for the purpose of. This is for the purpose of application, for the purpose of application development, for the purpose of application development. Yeah, for the purpose of application development. Application software for the purpose of application development. See, applications, apps, like some examples yesterday we discussed, right? Apps like WhatsApp, okay, like WhatsApp, okay, Facebook, next Flipkart. There's some applications, banking applications, banking apps, okay, next online trading applications, online trading apps. Yeah, there are different kinds of apps, right? Yeah, these kind of applications, how to develop, to develop this kind of applications, we need some software. Yes, to develop these kind of applications, we need some software. That is nothing but it's application software. Application software for the purpose of application development. This kind of applications, developing this kind of applications, for this application software requires. Purpose of application development. Okay, application software. Best example, Java. Java is the best example of application software. Java is a mostly used application software. Java is a mostly used application software. Java, .NET. Yes, next Hadoop. Okay, next. Yes, Python. Okay, next databases. So these all are application software. Databases, like different kind of things. All the applications. Okay, see here. In software, there are many technologies. See, more than 100 technologies we are using software. Yes, more than 100, many technologies. So many technologies. Okay, yes, many technologies. So many technologies we are using, right? Many technologies, like some languages we are using, some tools we are using, some packages, languages, tools, and packages. There are many things we are using, right? Languages like C language, Java, C++, Python, HTML. Yes, shell script, like this scripting language, programming language, like many things we are using. Tools, many tools, like warehousing tools, big data tools, next testing tools, reporting tools. Like this, there are many tools we are using. Packages, like ERP packages, like this, many things. So exactly which is application software and which is system software. See, only OS can interact with the hardware components. See, of course, here device drivers also interacting with hardware components, but device drivers are part of OS. Device drivers, it's a part of OS. Okay, so only operating system can interact with hardware components. That means except OS, all are application softwares. That's it here. Yes, many things we are using. So except operating systems, except operating systems, except operating systems, all are application softwares, all are application softwares, all are application softwares, except OS, except operating systems, all are application softwares. That's it here. 1 second. Let me open our class document. Yes, class document. See, guys, running notes is not necessary. Just 1 second. This is today morning. This document was updated. Today morning, 8 o'clock batch. With 8 o'clock batch, this document was modified. So this is your document, class document. See, in class document, yes, very clearly prepared everything. All prepared very clearly. Just you can follow the document here. See here, running notes is not necessary. Yes, just you follow document here. See, introduction to software from the beginning, from the scratch, prepared in these documents. Yes, what is your software? Yes, software basically two categories, like system software, application software. Okay. Yes. So till now, whatever discussed, same thing is there. Yes, system software, it interacts with hardware components, device drivers and operating systems. Example, application software for the purpose of application development. Example, their application softwares. See, except operating systems, all are application softwares. So till now, whatever we discussed today, yes, it's there in document here. Yes, you guys don't worry about documents. Running notes is not necessary. Try to understand class very clearly. Of course, repeatedly I will explain 2 to 3 times every topic, 2 to 3 times repeatedly I will explain. So first of all, try to understand the class. Okay, focus on the class, concentrate on the class here. Just to concentrate. Don't write any running notes. Running notes is not necessary. Try to understand concepts clearly. Okay. Yes, in documents, yes, everything is there. Everything is there in documents. Okay, see explanation. Sometimes I'm using notepad. Sometimes I'm using Word also. Word also here. So what are the topics explaining? Okay, explaining in the Word and notepad daily classes. Daily classes documents. It's there in yes in actual document. Every point is prepared in documents. Even single line also not missing. Single line also not missing. Everything is there. Just to follow the document. Simply just to follow documents. Okay, fine. Let us continue. See, except operating systems, all are application software. Okay, so system software, application software. Okay, fine. Now let us discuss about OS. What is OS? Okay, about OS. Okay, yes, about OS, operating system. Okay, here some question for you guys. Some question. Yes, can we run any program without OS? Yes, answer yes or no. Yes, come on, guess. Anyone, can you answer this question? Simple question asked. Of course, I'll explain. Of course, I will explain. Don't worry. Of course, I'll explain. Just I'm asking your idea. Just you can share in the chat box. Chat box available. Need not to speak. Chat box available. Yes, somebody. Yes, somebody pinging in WhatsApp. Yes. Here answer. What is yes? Can we run any program without OS? Yes, most of the guys are saying that no here. Okay, most of case. Okay, answer is no. Yes, OS required. If no OS, no computer. Without OS, no computer. See, except bias. Except bias to run all programs OS required. All programs OS required here. OS required. Except bias. See, except bias. Except bias to run all programs OS required. What is bias? What is bias? Bias stands for yes basic. Bias stands for yes basic. Yes inputs. Basic inputs and output system. Basic input and output system. Basic input output system. Basic input output system. Okay. So bias stands for basic input output system here. Okay. So bias. See bias. Okay, bias. Yes, basic input output system. What's the role of bias? So what is exactly bias? Bias. See, bias is a hardware program. It's a hardware program. Bias is a hardware program. Bias is a hardware program. Okay, hardware program. Yes, it is a chip level program. It's a chip level program. It's a chip level program. Chip level program. Okay, then what's the role of this bias here? What's the role of bias? Yes, bias is the responsible. Bias is responsible. Bias is responsible. Bias is responsible. Yes, responsible. Yes, to boot operating system. BIOS is responsible to boot operating system. To boot operating system, BIOS is responsible. Booting OS, right? See, before starting OS, first BIOS program will start. Once you power on your computer, first of all, the power goes to BIOS chip. The BIOS program starts. BIOS program activates. Once you power on your computer, that power simply goes to BIOS chip. The BIOS chip activates. Then BIOS program starts. Yet that BIOS program is responsible to boot operating system. Okay. So what is booting here? What is booting? Yes, booting. What is booting? Yes, booting is a process. Booting is a process of loading. Yes, booting is a process of loading OS from RAM memory. Yes, RAM memory to hard. Sorry, from hard disk to RAM memory. From hard disk. Yes, from hard disk to RAM memory. OS operating system. Okay, like Windows OS, Linux OS, all these are operating systems. Windows, Linux, all the operating systems. Okay, so booting is a process of loading OS from hard disk to RAM memory, Fine. So this is role of BIOS. Okay, role of BIOS. So once you power on system here, that power first of all goes to BIOS chip. BIOS chip is a part of motherboard. BIOS chip is a part of motherboard. So first power goes to BIOS chip. Yes, in BIOS chip there is a BIOS program, hardware program. That program activates and loads OS from hard disk to RAM memory. Yes, once OS is loaded, your system is ready. Now system is ready. Now this OS is responsible to take any request here. Okay, yes, this OS is responsible to take your request and processing request here. Taking and processing your request here. Okay, let us see about OS. Okay, now about OS. Okay, see. So what is operating system? What is operating? Let us see about OS here. What is operating system? About operating system. What is operating system? So what is operating system? About OS. Okay, let us see. See, computer. Yes. Yes, here there is a hardware. Okay, on top of hardware, OS is running operating system. Okay, operating system. On top of hardware, operating system running. Okay, on top of OS, yes, everything is running like C program, C++, Java program, yes, maybe some database. So yeah, all are on top of OS. Even Python scripting also top of OS. Even suppose Hadoop also on top of OS. Okay, right? Even for MS Office also OS required. See, all these are running on top of OS. See, on top of OS, hardware, on top of hardware, this OS. On top of OS, all of these running, right? So these are what application softwares. It's application software layer. Yes, application software. These all are application softwares. Okay. Yeah, all these application softwares running on top of OS. So OS, it's giving platform. OS giving platform to run all the programs. So what is operating system? Simple answer. It's a platform. Yes, it's a platform. Yes, it's a platform. Yes, where yes we can run all the application softwares. Okay. Yes, it's a platform where we can run all the application software here. It's acting like a platform. So OS, what is OS means? Simple answer. It's a platform. Platform means OS. See, Java is independent of platform, right? That means independent of operating system. Platform means OS. Okay. So Java is independent of platform, means Java is independent of operating system, means Java program running on anywhere here. If the topic we'll discuss next. How Java made us independent of platform. Next coming topic. Okay. So what is OS? It's a platform where we can run all the application software. Fine. See, OS, not only platform. OS not only platform here. Suppose this program generating some output. This program generating data, output data. Yeah, this output data first of all delivered to OS. First of all delivered to OS here. From the OS, then sent to output device. Okay. So whatever data delivering here, whatever data generating, the data first of all transfer to OS, from OS to hardware. Okay. See here, application software. Yes, through the OS, it can communicate with hardware component. Directly cannot communicate. Application software directly cannot communicate with hardware. So between application software and hardware, there is a OS. Okay. Yes, output of all the programs. First of all, deliver to OS and then transport to output device. Suppose input data. So first of all, input data goes to OS. So keyboard data goes to OS and then transfer to these programs. Suppose C program reading data from the keyboard, scanf. C program scanf, reading data from the keyboard. So first of all, keyboard data simply transfer to OS from the transport of C program. Similarly, Java, Python, yes, all the programs. Okay, all the programs, yes, taking data, yes, from the OS. So a keyboard to OS to programs. Next reverse. So between application software and hardware, there is a OS. So like a mediator. Yes, OS like a mediator. So exactly you can see it's interface. Just it's an interface. So OS, it's an interface. Yes, it is an interface. It's an interface. Yes, between it's an interface between yes application software, application software and hardware components. Application software and hardware components. Okay, so what is OS? Yes, it's a platform. So first point, it's a platform. Not only platform, acting as interface. Interface means mediator. Interface between application software and hardware components. Application software layer and a hardware layer. That's it here. That's it. Next, one more important point. Yes, one more important point. See, in OS there is a library. Yes, inside the OS there is a library here. See, inside the OS there is a library. This library. Okay. Yes. What is library exactly here? Library contains all the functions, input, output functions, C language functions. See, operating systems were developed in C language. Unix in C language, Linux in C language, Windows in C language. Okay, these operating systems. One second, let me have some more. Yes, almost all the operating systems developed in C language. So library means all C language functions like input output functions. Yes, input output functions. Library contains all input output functions. Okay. See, every ways has its own library. Every ways has a library to communicate between application softwares and hardware components. Yeah, this is very, very important for the Java perspective. In Java perspective, these are very, very important. Okay. See, every ways has its own library to communicate between application software between application software and hardware components. Okay. Yes, library. Yes, OS inside the OS this library. So OS using library to communicate between application software and hardware components. Next, one more thing here. These are all the programs. First of all, links with OS library. Yes, C programs, C++, Java, all the programs. First of all, linking with OS library. Using library, communicating with hardware components. maybe output device, input device. Okay, here these programs first of all links with OS library. After linking with OS library, then communicates with hardware components. Okay, see every program has to link with OS library. It's compulsory here. Every program, all these programs have to link with OS library. After linking, then communicates with the hardware components. Here that linking may be statically linking or dynamically linking. Statically or dynamically. Suppose if it is C and C++, statically linking. Java and Python is a dynamical linking. Java and Python are dynamically linking. Yes, we'll discuss. What is statically linking? What is dynamically linking? We'll discuss. Okay. Yes. So here C++, Java, these all the programs. Yes, every program first of all linking with OS library, then communicating with hardware components. So every program has to link with OS library before going to start. Before going to run the program, first of all links with OS library, then executing. That's it here. Okay. See every program. Yes, has to. Every program has to link with OS library. Yes, before going to run. Before going to run. Okay, before going to run. Yes, it's compulsory. Every program. Yeah, this is most important point. Fourth point, try to remember this. Okay. In Java perspective, very, very important. Okay. Every program has to link with OS library. It has to link with OS library before going to run. Okay, that may be statical linking or dynamical linking. Suppose C and C++ statical linking. Java and Python is a dynamical linking. Yes, we'll discuss that next topic. Okay, so this is just the idea about OS. So what is OS means? Simple answer is a platform and acting as interface between these two layers. Right? So this is just about OS. Enough. This knowledge enough to understand Java features. So this is about OS. Okay. See same points explain document here. See OS. All the 4 points here prepared here. It's a see this OS. Okay, fine. So this is about OS. Okay. Yes. Software. System software. Application software. See Java comes under system. Java is application software. Java is application software. Now
Hello, sir.
let us go to application. Yeah, tell me. Tell me,
Sir,
Abhishek.
I'm not able to see the chat window.
No. Yes, other guys are able to share their doubts. Yes, I think to organizers only. I think chat window with organizers only.
But it is not showing here in the laptop. Maybe it is coming in the app, mobile app. But
No. Not in laptop only coming. It's
It
coming
is
other.
not showing in.
No, sir, it's not coming. It's not showing on the laptop.
In laptop,
Laptop or mobile is not showing either.
yes, sir. In laptop, not showing. Me too using laptop, sir. And nowhere it's showing chat box, sir.
Not
Even
showing
I'm
chat
using
box.
application.
Okay. I think maybe yes. Something wrong with yeah. Yes. Somebody is sharing. Please, for 1 second.
Sir,
Yes,
only in this time only this like this set is appeared, and in previous also like this happened, sir. Chat box.
no. Only today happening like this. Not yes. It won't
Okay.
happen like.
Okay.
See,
Yesterday also nowhere I find, sir.
1 second.
Okay.
One more thing.
Hmm.
Yeah, one more thing. Yes. So next we'll be moving to GoToMeeting app. Once moving to GoToMeeting app, yes, everything will be enabled. You can clear.
For this trial period only, we are using right now this one, no? For
Yeah,
summer
right now
onwards, I think
this.
so.
Yeah. These 2 classes we are using GoToTraining app. After 2 or 3 classes, we'll go to GoToMeeting. That time
Okay,
it
sir.
won't happen like this. Okay.
Okay,
Fine,
okay.
sir.
Done, sir.
Fine, sir. Take it, sir. Thank you. Proceed,
Yes.
sir.
These are problems happening with only GoToTraining. Only GoToTraining. Once move to GoToMeeting, it won't happen. Second GoToMeeting, yes, we can see clearly the chat box. Okay. Yes. No worry.
Okay.
Okay, proceed, sir. Thank you.
Even for me also not showing today. Yes, only, yes, entire audience, only one option is available for me. Yes, is not showing all options. I think, okay. Yes, tomorrow just I will talk to online team. Yes, suppose, yeah, online team, they are at the time of launching app, some options are missing with online team. Yes, I'll talk to online team. Okay, tomorrow class, it won't happen. Tomorrow class, I'll do it. Okay, yes. Yes, otherwise tomorrow class, I will launch. In tomorrow class, I launch from my laptop. Instead of online team launching this app here, I will launch from my laptop. So it will be easy, clear. Yeah. Okay, fine.
Okay.
Now, here software, here the system software, next application software. Okay, application software. Okay. See here, Java comes under application software. Java is a application software. Java is application software. So let us move to application software. Yes, let us move to application software. Yes, Java is application software. Let us see about application. So our topic is application software. Yes, here application software. 1 second. See application software. Get two categories like front end, back end. Front end, back end. In application software, there are two categories: front end, back end. Front end, back end. 1 second. Let me have some water. Let me have some water. Yeah. So let us continue. So here in application software, this is a front end, back end. Front end and back end. So what is front end? What is back end? See here, go to training. Here is a form, right? Here is a form. Yes, in form we are filling form details and submitting, right? Just filling this form and submitting. Yeah, this form taking data from us, right? This data. Yeah, this form is a front end. This form is called as front end. This form is a front end. So it's taking data and storing it some location. Storing into some location. That location is a backend. Backend is to store the data. Front end is to collect the data from users, end users. Okay. So front end, it collects data from users and stores into backend. So front end, yes, it interacts with users. It collects data from users, stores into backend. So backend is to store and maintain data. Example, databases. All the databases are backends, like Oracle database, MySQL database, Microsoft SQL Server. They are databases to store data. Files like Linux files, Windows files to store data. HDFS, Hadoop distributed file system. Hadoop distributed file system to store huge amount of data. So data storage purpose, they are backends. Yes, Java is a front end. See here, behind of this form, this is a Java program. It's a JSP. This form developed in JSP. This form developed in JSP. Okay, JSP is a Java program. So behind of this form, this is Java program. The Java program taking data. Java program taking data. So it's a Java comes out front end. Java is a front end. Now let us move to front end. In front ends, languages and packages. Yes, packages are ready-made and ready to use like MS Office, ERP, these things. Okay. Yes, languages. In language, we should write the code. Yes, Java comes under languages. In languages, programming. It's a programming part. Java comes under languages. Now, yes, let us move to languages. Okay. See, the way introducing it to Java. Okay. Try to observe it here. Yes, way of introducing it to Java. See, first of all, software. See, computer ware, hardware and software. We are the software engineers. So started software. Yes, software. System software, application software. Java is application software. So move to application software. Yes, in application software, front end, back end. Java comes under front end. Yes, in front end, language and package. Now Java is a language. Java comes under language. Java is a language. Okay, let us say about languages. Okay. Yes, about languages. Yes, language. What is language? Yes, what is the language? Simple answer. It's a media of communication, right? Language is a media of communication between two persons or two animals or two trees, any two living things. Two living things. Okay. Yes, come to software. Software languages. Software language. See software here. Software languages. See software.
Sir, once can you show the table, sir?
This one.
1 second. Yes, 1 second.
Yes. Yeah, this document for you only. I'll share this document. Don't worry. This document for you only. Okay. Yes, I'll share with you. Yeah, tell me. You want me to repeat once again? See. Hello. See, software, system software.
Can you show the language document, sir?
See here, introduction to software. Okay. Yes, software basically two categories. System software, next application software. Java is application software. Okay, so before moving to application software, something explained about OS. Yes, so explained about OS. Now, moving to application software. See, application software. Basically two categories. Front end and back end. Java is a front end. So moving to front end. So front end means interact with users here. Back end is to store the data. Java comes under front end. So moving to front end. In front end, language and packages. Okay. Yes, Java is a language. So moving to languages. That's it here. Now our topic is languages. Topic is about languages. Okay. Software languages. See the document for you only. I'll share with you. After finishing class, just go through the document here. Today after finishing class, I'll share it. Just go through it. Read the document. See, every day after the class, just go through the document here. Read the document. Okay. See, whatever topic I'm explaining class here, it's there in document. I have prepared very clearly. Just to prepare the document. So running notes is not necessary. Yes. Are you trying to write notes here? Are you writing any notes? No. Don't write any notes. Just watch the class. Try to understand it here. Yes, read the document every day. After finishing class, every day read the document. You can understand very clearly. Okay. Yes. Let us say about software languages. Okay. See in software. See, we are understanding some language. We are understanding some language. For example, here C programming. For example, C program. See, this is some C program. Right? Looking like English language. This is like English language. Looking like English language. English language, right? Suppose let us take Java program. Suppose some Java program. Java program. Java program. Suppose Java program. See, this is like English language. Python scripting, HTML, all are like English language. So English language, that is user understandable language. Okay, right? Next, computer understanding different language. What is computer understandable language? We'll see. Software languages. First one, computer. Yes, computer. Yes, understandable. Computer understandable languages. computer understandable language. Next, second one, yes, user understandable language. User understandable language. User understandable language. So first one, computer understandable languages. Second one, user understandable language. See, computer understandable language. Computer understandable language. Okay, so that depends. So this one depends on, yes, generation of computers. Generation of computers. See, here's one more question for you guys. One more question. See, how many generation of computers? How many generation of computers? Anyone can answer this? Very basic question, simple question asking. Okay. Yes, you guys don't worry. I'll explain very clearly. See, same question just you ask working guys. Okay, suppose any of your friends working Java, maybe other fields. Okay, maybe 10 years experience. Just ask them, no answer. They will not answer. Simple learning, software and doing jobs. Okay, see, I wanted to explain everything here. Yes, including basics and everything here. Okay, so how many generation of computers? Anyone idea? Generation of computers. Yes, see here, knowledge, acquiring knowledge. You have to, yes, you have to gather a lot of information. You should have a lot of knowledge. See, for knowledge purpose, I'm giving this much of information. They're basics. Basics. Just before going to Java, there are some basics. Only one class, not more than that. Only one class. After that, we'll go to Java. Okay. Yes. How many generation of computers? How many generation of computers? Anyone idea? No idea? Yes. 5 generations. 5 generations. 5 generations. Yes. First gen. So what is first generation computer? Here, first generation. Yes, first generation, it's a vacuum tubes based computer. Vacuum tubes based. Okay. Second generation. What is second generation? Second generation, yes, transistor based. Yes, transistors based. Okay, transistor based here. Okay. Yes, first one vacuum tubes. Next is transistor based here. So next one, yes, next generation, third generation, IC based. IC based means integrated circuits. Okay. Yes, in our engineering we have one subject, electronic subject. This electronic subject we have one subject. Okay, very interesting topic. Vacuum tubes, how these tubes are working, how transistors are working, integrated circuits, how they are working. Okay, somewhat interesting topic. Okay, so totally 5 generations. First generation, second generation, third generation. Yes, so fourth generation. Now fourth generation. What's a fourth generation? What is fourth generation? What is fourth generation? Anyone idea? Fourth generation. Yes, it's a processor based computer. Yes, now this is present generation. This is present generation. Yeah, this is present generation. Okay. Next, fifth generation, it's a future. Fifth gen. Yes. Tell me guys, can you guess it? Yes, what is next coming generation? Yes, what is next generation computers? Yes, almost two. Yes, it's going to release in couple of weeks, be releasing into market. Yes, by 2025. Yes, by 2025 coming to market. Yes, what is fifth gen? Yes, someone is trying. Yes, can you speak loudly?
Artificial intelligence, AI based.
Yes, right. Good. AI based. So AI based computers. So next is AI based computers. See here, processor. Now present generation is processor based. Okay. So processor based computer understandable language. So what is this processor based computer understandable language is? Language is a binary code. It's a binary code. So binary codes. Yes, it is like a zeros ones format. Okay. See, AI based. So AI based. what is AI based understandable language? So AI based computer understandable language. Yes, anyone idea? AI based computer understandable language is English. It can understand English. English. Direct you can speak. So what are is speaking computer can understand. So once computer is able to understand our English here, things becomes easy. So much programming reducing. This we are writing lot of programming, right? Okay. Yes, much programming reducing here. So with the help of AI based computers here, okay, just speak English, they will understand here. Okay. So things becomes easy. Everything becomes easy here. Right? Okay. So that is AI. That is a feature. Feature is a AI based computer. AI based computer. Yes, it's English language. It can understand English. It can understand English. Okay, it can understand English. For example, here, suppose when you're traveling in a car, suppose you wanted to open door. Okay, after stopping your car, yes, just you have to say some code. Automatic door opens. That is one example. AI based computer. Yes, suppose if it is yes, that car completely automation. Okay, when you're speaking something here, automatically that AI based car, that voice will recognize, will open the door. Opening door. Okay, so whatever you want to activate some activity, automatically happens here. Okay, that is AI based computer. In future, yes, we are expecting 2025. Yes, if not possible, at least 2030 may be possible. 2030, 100% coming to the markets. Okay, yes. So this is about AI based. So now presently it's a processor based. Processor based. It's a binary code. Yeah, this language called as low level language. This language called as low level language. Okay. See, user understandable or high level language. English language. C program. Yes, Java program like English. See, Java program like English language. Okay. C program like English language. So these are high level languages. C, Java, C++, and all these high level languages. Okay. So in software, yes, software languages. Yes, basically two categories. Okay, software languages. Yes, software languages. Two categories. First one, low level languages. First one, yes, low level. Yes, low level languages. Second one, yes, high level languages. Second one, high level language. Low level and high level language. Okay, low level language and high level language. Okay, so what is low level language? Low level language, it's a computer understandable language. It is a system understandable language. Low level, yes, it's a system. It is a system understandable language. System understandable. Yes, it is a system understandable language. It's a system understandable language. Okay, here system means yes, it's a system understandable language. Okay, yes, it is in the form of binary codes, like zeros ones formats. So here system means processor. System means processor. It's a processor like 8085 and 86. Now currently we are using 8086 processor. Currently we are using this processor. Okay, before 90s 8085. Now we are using in 90s period, from 90s period 8086. Okay, yes, it's a system understandable language. It's a system understandable language. It is in the form of binary code. Yes, it is called as it is called as machine language. It's a machine language. It's a machine language called as machine language. It's a machine language. System understandable language. Okay, next, high level language. So what is high level language? High level language, it's a user understandable language. It is a user understandable language. Right? Yes, like English, they are like English. Okay, like English language, like English language. Yes, very easy to understand. Very easy. They are very easy to understand. Like C programming, C++, Java, and all this here. Very easy to understand. Okay. Yes, examples. Examples. Java is a high-level language. C is a high-level language. C++ high-level language. HTML high-level language. Python high-level language like this. High-level language. Okay. Now here some question for you guys. Some question. Yes, very simple question. Very simple question. Yes, which is first high-level language? Which is first high-level language? Yes. If you're able to share in chat box, you can share it. Otherwise, you can speak it. No issue. Which is first high-level language? Which is level language?
C++.
Yes. Which is first high-level language?
Sir,
Which
C.
is first high-level language? Yes. C language.
Pascal.
C language.
C
Later
language.
C is first C language.
Pascal.
C language. C language. Yes. C language. C language. C language. C language is a first high-level language. First high-level language. Yes, developed in the year 1972. 1972. C language is a first high-level language developed in the year 1972. Yes, who has developed C language? Who has developed C language? Anyone idea? C language developed by whom? Yes, who is the author of C language? Who has developed C language? Anyone idea? Yes, if you're able to ping, you can ping in chat box, otherwise you can speak. Yes. C language developer. Yes, who has developed C language? No idea? Okay, fine, no problem. Yeah, Dennis Ritchie. Okay, first C language. After C language came to market, everything is developing C language only. C++ from the C language. Java from the C language. Okay, next step. Python from the C language. COBOL from the C language. Pascal from the C language. Many languages are developed from the C language. C is the basic. C is the basic language in the computer field. Okay, even every operating system developed in C language. Unix in C language. Linux in C language. Yes. Windows in C language. Okay, right? Yes. So here C is a first high level language. Okay. See here high level language. This high level language. See every high level language program has to convert into binary codes. Yes. C program converting into binary. Yes, system has to understand. System understandable language. This high level language program. Yes, maybe Java program or C program. These programs have to high level language. These programs have to convert into binary codes. Yes, we will convert high level language to binary code, system understandable language. Which one will convert here? Which one will convert from high level language to binary code? Any idea? Any idea? Which one will convert from high level language to binary code? Yes, which one will convert from high level language to binary code?
Compiler.
Yes, good. Compiler. Next, any others?
Virtual machine
Yes,
Java.
interpreters. Yes, interpreters. Good. Interpreters. See. Yes, interpreters. Yes, interpreters and interpreter and compiler and compilers. Interpreters and compilers. Okay. Interpreters and compilers. Converts. Interpreters and compilers. Converts. Yes, converts from high level language to binary code. Okay, So interpreters and compilers convert from high-level language program to yes binary code. Okay, right? Yes. So what is interpreter and compiler? Let us see about this. Interpreter and compiler. See, interpreter and compiler. See, interpreter and compiler both are doing same job, converting from high-level language to binary code. But there is a difference. There is a difference here. What is difference here? Interpreter versus compiler. Let us see about interpreter versus compiler. Okay. Yes. Yes, interpreter versus compiler. See here, every topic is there in document here. Yes, don't worry guys, it's there in document here. See what we discussed today now. Software languages, computer understandable, user understandable. Okay, computer understandable depends on generation of computers. There are 5 generation of computers. First generation, second, third, fourth. Yes, all prepared. All are prepared here. Okay. Yes, next software language, 2 categories, low level language, high level language. Low level, about low level expand here, about high level language expand here. So which is first developed high level language? C language, same, all are expand here. Okay, see every high level language program has to convert into binary codes. High level language to binary codes. Yes, for this interpreter or compiler convert from high level language to binary codes. Now topic is about yes, interpreter and compiler. Topic is about interpreter and compiler. Let us see interpreter and compiler. There are many differences. Let us see. Yes, interpreter versus compiler. So interpreter versus compiler. Yes, anyone idea how interpreter working, how compiler is working? Yes, interpreter versus compiler. For this purpose, interpreter. First, let us see about interpreter. For this purpose, I am taking Python scripting. Python is an interpreter-based language. Some test.py, some Python script. Yes, how that Python script is working? Yes, let us take some Python script. Yes, let me show practically. Python. Yes, here in Python, PyCharm ID is there. Yes, we are using PyCharm ID for Python script development. Yes, PyCharm ID may be difficult to understand for you. Okay, better go with the Notepad. Yes, we'll go with Notepad. Yes, we'll go with Notepad. Support D drive, sample folder. Support D drive sample folder. Here, this folder I'm using to develop Python scripting. CMD, command prompt, go to command prompt. From this D colon means that will take to D drive. So here sample directory, CD means change of directory, change to sample, changed. So DR, yes, nothing, empty. 0 files, no files. Now I'm using Notepad. Yes, test.py. Do you want to create new file? Yes. Okay, now here simple program. A is equal to 10. Yes, B is equal to 20. Okay, C is equal to A plus B. Just adding 2 numbers. Yes, print. Yes, addition. Yes, addition is equal to displaying C value. Yes, in Python, semicolon is optional, not necessary. Semicolon is not necessary. C equal to A minus B. Yes, next here is a subtraction. Subtraction equal to. Okay, next. Yes, multiplication. So next multiplication. Yes, multiplication equal to. Okay. So A equal to 10, B equal to C equal to A plus B. So displaying addition. After C equal to even subtraction, next A into B multiplication. Save and exit. Yes. See here. Now this is test.py Python script, right? Yes. How to run this one here? Suppose if it is C program, first of all compiling C program, right? C program means you have to compile it. If no errors, you have to run it. Now in Python scripting here, no compilation process, directly running the script here. Directly executed. Python is a interpreter-based language. Yes, interpreter never checking for errors initially, directly program execution. Python interpreter, not only Python, any interpreter will execute program directly. There is no prior checking for errors. Suppose compiler is first of all checking for all the errors in the program. If no errors, then executes. But interpreter, any interpreter, not only Python, HTML interpreter, next PHP interpreter, Perl scripting interpreter, Linux shell scripting interpreter. Okay, like any interpreter directly executes. That program executes directly. See, program executed directly. Okay. Yes, here, what happens here? Yes, in scripting, how that interpreter working? Let me explain how it's working. That interpreter, how it's working. See, in Python scripting, first statements, A equal to 10, yes, B equal to 20. So next statement, C equal to A plus B. Next, print addition equal to C value. Next, C equal to A minus B. Yes, print subtraction equal to C value. Yes, next, C equal to A into B. Next, multiplication, these statements. So these are scripting statements, right? Assume that these are scripting statements. These statements. Okay. Notepad. Yes, these scripting statements. These scripting statements. So these are just assume like our scripting statements here. Yes. How it's working? First of all, interpreter checks the first line. Checking first line. Suppose first line is correct. Simply that interpreter, Python interpreter converts that code into binary codes. First line converts into binary format. That binary format given to processor. So processor executing and generating outputs. Okay. See here, interpreter checks the first line. Suppose first line is correct. Simply converts into binary code and given to processor, generating output. See, next coming lines may be right or wrong. Yes, interpreter never think about next coming lines. Not only Python interpreter, any interpreter never thinking about next coming statements. Suppose if that statement is correct, converts into binary code, then executes. After that, checking for next statement, second statement. Suppose second statement also correct, same thing happens, converts into binary code and given to processor, generating outputs. Second statement are same here. Okay. Yes, next statement. Suppose something wrong at next statement. Something wrong here. Stops. That's it. Yes, it won't go to next coming statements. Any error comes, simply stops. Yes, any error comes, interpreter stops. Any error is there, stops. It won't check for next coming statements. Any error comes, simply stops. Let me show that. See. Here, 1 second. Notepad. Let me open this. See this. Suppose there are some errors. Suppose here comma missing. Okay. Suppose here double quotation missing. Suppose here bracket missing. Totally 3 errors in this program. 3 errors. 3 mistakes are there. Now run it. See. At line 8 line error, right? Only first error showed. Yes, addition equal first error. First error showed it. Others not displaying. So whenever any error comes, simply stops. Any error comes, simply stops. Okay, invalid syntax. So here error, 8th line error, stopped. Now let us correct that mistake here. Yes, 8th line, that comma missing, right? Comma missing. Save. Okay, after saving, now again run it here. Again run it. Yes, now it's showing next error. That means showing only 1 error, right? That interpreter showing only 1 error, not 12 line error. It's not showing all the errors at a time. Only one error. Okay. Yes. Now correct this mistake also. This one. Yes. After correction, save. Control yes, save it and exit. Now run it. Yes. Next error. 70th line error now here. 70th line error. Okay. So what's happening here? It's showing only 1 error at a time. Only one error at a time. So this is here missing here. Save. Yes. Now Run it. Yes, now got the output. So this is working of interpreter. So how interpreter working? Line by line. Yes, see, checking first line if it is correct, then executing. Next line correct, executing. Any error comes, simply stops. This is the interpreter. Okay. Yes. Suppose compiler. The same thing. How compiler working? Let us see about compiler. How compiler working? Yes. Now let us see about compiler. Yes, about compiler. Now about compiler. Yes, for this C program. Let us take C program. C is a compiler based C program. C program. Support test.c file, for example. C program. Yes, how it works. C compiler. How it's working here. C compiler checks the first statement. Suppose first statement is correct. First statement correct. Even correct, it won't convert into binding code immediately. No, it won't convert. It won't convert. It won't convert. It won't convert. Okay. Yes, next checking for next statement, second statement. Suppose second statement also correct. Even correct, it won't convert. Now checking third statement. Suppose something wrong here. Error yet third line. Error at third line. After checking for next statement also. Like this, compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. See error at this line. Error at next line. So next line, top to bottom. So top to bottom, top to bottom. Suppose one more error. Yes, it shows all the lines from top to bottom. Compiler shows all the lines from top to bottom, all the errors from top to bottom. Compiler checks whole program. Interpret is line by line only. Line by line checking. Any error comes, interpret stops. But compiler is not like that here. Compiler checking whole program from top to bottom. Every line checking top to bottom and shows all the errors. Shows all the errors. Okay. Next, we should correct all the errors. We should correct all the errors. Okay. Yes. We should correct all the errors. After correction, recompilation. After correction, recompilation. Suppose next time, no errors. Everything is fine. Okay. Let me show. Practical example. C language. Just where is C? Yeah. This is C language. C program. Yes, C program, C++, both are same. C math.cpp file. Math.cpp. C and C++ both are same. See this is C program. Yes, program to add, subtract and multiply two numbers. Here also taken same program. ABC variables, enter first number. C enter first number, enter second number. Next C equal to A plus B, C equal to A minus B, C equal to A into. So this is C program. Okay, compile. Yes, success, no errors. Run it here. Now first number 10, second number 20. Yes, output addition 30, subtraction minus 10, multiplication 200. Now suppose some mistakes in the program. Suppose semicolon missing here. Suppose here bracket missing. Okay, suppose scanf here comma missing. Okay, something like suppose here semicolon missing. Okay, so printf here. Yes, suppose here double quotation missing. Okay, something missing. Suppose here semicolon missing. Okay, suppose here this bracket missing. Yes, now save it. Saved program. Now let us compile. Now compiling option, compile option, only compilation. Compiling, see errors. See, there are 9 errors showing here. 9 errors. Yes, 9 errors. Press any key. 9 errors, press any key, enter key. Now see this. See at the bottom. Yes, line number 14 error. Line number 18 error. See, line number 22 error. See at the bottom showing this is. See, try to observe it. Down arrow key. Next error. Down arrow key. Next error. Down arrow key. Yes. 25th line error. 27th line error. 29th line error. 31 line error. 38th line error. 40th line error. So top to bottom. Here this is compiler working. Compiler checks whole program from top to bottom. All the errors from top to bottom. Yes, all 9 errors. These are list of errors. List of errors. Compiler shows all the errors in program. Yes, now let us correct these mistakes here. Semicolon missing here. Yes, here bracket missing. Okay, here comma missing. Okay. Yes, next here, semicolon missing. Okay, next here, yes, printf, double quotation missing here. Okay, let us compile. Yes, still errors, 2 more errors. Okay, if this semicolon missing here. Next here, this is bracket missing. Yes, compile, success. Success. Okay, now what happens? On success, what happens here? Success, no errors. If no errors, what happens here? Yes, if no errors. Now, if no errors, everything is fine. Then compiler opens another file, one more file. It opens another file. It opens one more file. After opening the second file here, it converts whole program into binary code right to this file. First line binary code right into here, second line binary codes, next statement binary codes, top to bottom. All the lines converts into binary format right into some one more file, right into that result file, right into one more file. Right? Yes, this result file is called exe file. Exe means executable file. Exe means executable file. Not test.c. That conversion some test.exe file. Test.exe file. The test.exe file given to processor finally. Now processor taking that exe file, executing all lines at a time and giving output. That's it. So what is happening if no errors? It generates one exe file. That exe file given to processor generating output. Yes, let me show that exe file. See backend of this program, math.cpp, backend. Let us go to backend, turbo C, C drive. Here turbo C installed. Yes, bin folder. Inside the bin folder, all the programs. That math. Yes, yes, math. This is okay. 1 second. Let me delete some existing one. See math.cpp. Okay. See here, this is backend math.cpp file here. Just 1 second. Just a minute. It's not saved. 1 second. Yes, save. Okay, fine. Okay, now here it's compiling. See this. Now I'm compiling here. 1 second. Here this math.cpp, this file. So the backend program. Okay, now let us compile now run it. When you try to run it, what happens here? See, run it. So when I run this one here, see here backend, see this. Math application means exe file. That math.exe file generated. See that .exe file generated. .exe file generated. Not this exe file executing now. Yes, exe file executed. See that. Now enter first number 10, second number 20. Result addition, subtraction, multiplication. That's it here. That's it. So what's happened here? Yes, compiler generates one exe file. That exe file executes finally. That's it. So this is difference between interpreter and compiler. Interpreter and compiler. Okay. So interpreter compiler differences. See. Yes. Interpreter. Interpreter versus compiler. Let's see points wise. Yes, compiler. Interpreter and compiler. So interpreter versus compiler. The differences. Let us see differences. Yes. Now guys, tell me what's the main difference you observe here. See. In Python scripting, so that script executed directly. Test that source code executed directly. Yes, in compiler, what happens here? When you run this here, yes, that exe file created, right? And executed. So what is main difference observed here? See this. Yes. Yes, these 2 pages explanation. So these two, yes. One second. See these 2 pages. What is observed? Yes, you can see very clearly. Yes, able to see this. 2 pages. First page, second page. What's the difference here? What's the difference you observed in this first page, second page? Here this is difference, this extra, right? In second phase, what is this? It's exe file. So this is main difference. Okay. So compiler generates exe file, but interpreter does not generate exe file. This is the main difference. Difference between interpreter and compiler. Compiler generates exe file. Interpreter never generates exe file. See, interpreter Python scripting. See, test.py. If that source code executing directly. But in case of compiler here, first exe file generates, then executes. This is main difference. Let us see all the differences. Points wise. Yes, interpreter, compiler, differences, interpreter. So yes, interpreter, it checks the, yes, it checks quotes, yes, checks quotes line by line. Checking line by line, right? What is compiler? Yes, whole program, it checks, yes, it checks whole program, yes, from top to bottom, checking all lines from top to bottom, right? Yes, the interpreter checking only one line. So first line is correct, next line, correct, next line. Suppose something else stops, checking only line by line, but compile is all lines, it checks all lines, it checks whole program from top to bottom. Okay, right? Next, when come to output here, even output also line by line output here. Yes, line by, yes, line output, line by line output here. Output also line by line, but compiler, whole program. See, exe file generating, at a time executing, right? So at a time output. So this is at a time output. It's at a time output. Okay. Yes. Next, interpreter. Yes, it shows only one error. Yes, it shows only one error. It shows only one error. Only one error. Yes, compiler. Yes, it shows all errors from top to bottom. All errors from top to bottom. Okay. So interpreter shows only one error, but compiler, it shows all errors from top to bottom. Next, main difference. Yes, it does not generate. It does not generate exe file. Compiler, it generates exe file. Generates exe file. Okay, right? Yes, interpreter, it does not generate exe file. Yes, compiler generates exe file. See, interpreter, it executes source code directly. Yes, this is your source program. Okay, source program. Yeah, this code is called source. Called the source code. Yes, Java source code this is. Okay. Next, C program source code. Yes, Python scripting source code. Okay. Yes, it's a source code. The source code executes directly. Okay, interpreter. Yes, it executes source. Yes, source code directly. It executes source code directly. Okay. Yes, what is compiler? It executes exe file, not source code. It generates one exe file. Yes, it executes exe file. Okay, fine. See, interpreter based languages are called scripting language. It is all scripting languages are interpreter based language here. All scripting languages are interpreter based. Okay. Yes, they are programming language. Yes, all programming language. They are programming language. Okay. See, interpreter based languages are called scripting languages. Okay. Yes, interpreter based languages are scripting language. Compiler based languages are called programming languages. So these are programming languages. Right? Yes, examples, scripting language examples. Python. Python is the best example of interpreter based language. HTML. For HTML, yes, HTML, hypertext markup language. It's a browser understandable language. Browser is an interpreter for HTML. Browser. So this is browser, right? Browser is an interpreter for the HTML. Okay. Yes, next. PHP scripting language. Perl scripting language. Linux shell scripting language. Okay, just compile with examples. Programming language like C language, C++, yes, .NET, C#. Okay, fine. Now, simple conclusion here. See, interpreter-based language, interpreter-based language, don't have exe file, interpreter-based language don't have exe file, interpreter-based language don't have exe file. Simple conclusion here. Interpreter-based language don't have exe file. So here, yes, here everything is exe file. Yes, finally generating exe file. So everything is an exe file here. It's exe file. Okay, fine. See here some doubt here. Yes, this trainer MN Rao always talking about interpreter compiler C, C++. Yes, very Java. He's not talking about Java. Now Java. Yes, is it interpreter based or compiler based? That is doubt, right? See here. So these are compiler based. That's okay, fine. They are interpreter based. Okay, fine. Now where is Java? Java what? Java depends on what? Java. Yes, is it interpreter based or compiler based? What is Java? Is it interpreter based or compiler based? Yes, we should discuss about Java now. Yes, we should discuss about Java. Okay. See, actually Java comes under, yes, both. Java depends on both interpreter as well compiler, both here. How? Get the topic tomorrow discuss. Tomorrow we'll discuss. Okay. Tomorrow I'll explain about Java. Tomorrow starting Java. How Java is working. Okay. Yes. Yes. Is it interpreter or compiler? Yes. With example we'll discuss. Java program example. Like today Python and C programming taken it like that. Tomorrow I'll take the Java program. I'll explain about Java program. Okay. Yes. See, same topic it's in document. Interpreter and compiler. Okay, yes. See, Java depends on both compiler as well interpreter. So tomorrow explaining about Java topic. Java, this is Java. Tomorrow introducing into Java. So once you introduce Java here, yes. Next, Java features finishing. Tomorrow, this topic Java features finishing here. Next installation. So tomorrow, yes, Java introduction finishing. Next Friday, Java installation. How to install Java, how to install Eclipse. Programming starts on Friday. That's it. Okay, yeah. So that's all for today introduction. See, this is about interpreter and compiler. I hope everyone you understanding classes very clearly. Yes, guys, are you understanding clearly my classes?
Yes, sir. Yes, sir. It's very clear.
Yes,
Yeah.
sir. Yes, sir.
My classes are like a spoon feeding. Everyone can understand. Okay, even very interested. Yes, my classes will be, yes, going forward, you get more and more interested. See, generally here, most of the trainers, first 1 week, they will explain very interestingly. But going forward, losing interest. But my case, day by day, interest will be increasing here. You will see the difference. Day by day. Yes, interest, more interested. So once you entered into programming, you'll see more interest here. Logics, how logics are developing and all these things. Okay, yeah. So that's all for today. Yes, tomorrow, yes, going for Java, how Java working. Yes, is it compiler based? Is it interpreter? Java example we'll discuss. Okay, next, how Java made us independent platform tomorrow. Tomorrow Java introduction. So once Java introduction completed, next is yes, tomorrow class exe file dot class will difference. Very important topic. Don't miss tomorrow topic. Okay, see 1 second. One important note for you guys. See, you guys may be joining into my batches or not. That is secondary. Leave about it. But tomorrow class, don't miss it. Very important class. Tomorrow class you will not see anywhere. Okay, no Java website will give that kind of information. Tomorrow class topic here. Even no Java trainers will explain that kind of class. Tomorrow very interesting class. Don't miss it. Attend it here. Yes, you may be joining into my batch or that is secondary, but don't miss tomorrow class. Very important class. Okay, yes. Yeah, that's all for today. That's all. Yes, any doubts? Yes, if no doubts, yes, let us find up session for today. Yes, we'll continue for tomorrow. Tomorrow also same link, same time. Same link, same time. Okay.
No doubts, but share the documents, sir. Notes.
Yeah, I'll share the document. I'll give the drive access now.
Yeah,
Today,
okay.
today I will give the drive access definitely. Okay.
Okay.
Yes, today I'll give the drive access. Next, one more thing here. Everything will be informed in the WhatsApp group. The group created already. Yes, already communicating students. Even students also communicating each other. Okay. Even students also communicating each other. Group communication is going on. Still anyone to share about details. Yes, this is my WhatsApp number. I'll add to that. Yes, 8179-189-123. Okay. Yes, your name. Next. Yes, your Gmail ID. Okay, I'll add to group. See, anytime you can ping me. Okay, even you can call me on this number also. See, already your batch students are calling me. Okay, they are taking advice. Okay, yes. See here, not in subject, any other advice also you can ask me, no problem, no issue. Okay, just like a friend. Okay, just like your parents, just you can feel like your parents, I can guide you. If that guidance always will be there. Okay, see, not only this one here, lifetime support will be there for lifetime support. See, lifetime supports groups are created. Lifetime supports. Yes, groups. Yes, news, sharing information about job openings and all this. So whenever any requirement comes, I'll share in the group. Yes, even our company share in the group. Yes, like these groups. Yes, 6 groups means almost more than 1,200 groups are there. Sorry, more than 1,200 students are there. Okay, more than 1,200 students are there in these groups here. Yes, I'm communicating with them. Every communication, everything I'm sharing with them. So whenever jobs information comes and all that sharing, lifetime support. Even batch completed, I won't leave you. Okay, lifetime support will be there. So whatever you want information, I can share it. You can ask anytime here. Okay. Yes, compulsory job assistance 100%. Yes, he's my personally assistance, not from Durgasoft. Yeah, Durgasoft also they are providing job assistance. Okay. Yes, from my side also, I'm providing job assistance to my students here. I'm taking resumes for every student. Okay, after finishing course, I'm taking resume. Yes, I'm forwarding to different companies. Yes, that resumes, student resumes, all the resumes. Okay. Yes, you guys, if any still any pending, share your details. I'll add to group. Okay. Yes. Yeah, that's all. Let us wind up session for today. Yeah. So thank you guys. See you tomorrow. Have a great night.